So maybe I can wrap up this report with this particular podcast. Again, brief introduction. So this part looks at the research that is going on across the world and looking at the number of scientific papers that focus on CDR in some way or the other with various methods, CDR as a whole, geoengineering, afforestation, reforestation, ocean fertilizers, fertilization, BECS, DAC, enhanced rock weathering, biochar, soil carbon sequestration, and so on. So you can see that the number of papers has been up and down, with a peak in 2016. 2021 hit a high in the last decade. We'll see where 2022 ends up by the time all the papers are out. Keeping again in mind where we need to be, so we have the greenhouse gas emissions and just CO2 emissions. So CO2 emissions have to go to net zero earlier than greenhouse gas emissions, just in terms of the technologies focused on CDR. And already there is negative so drawdowns happening, but at some point we'll hit the irreducible levels of emissions in CO2 and greenhouse gases, and then the negative emission technologies or net negative state has to be reached, where we not only remove what we are emitting but more than that to stay on target for overall net zero and the global warming targets of 1.5 and 2 degrees C and so on. The distribution of publications has been uneven, China dominating as it does in renewable energies as well, but also burning a lot of coal. But you can see US is up there in the second place, with other countries like Canada, Brazil, India, and Australia playing some role, and lower number of publications from other countries. Not surprisingly, big lack of research in Africa and some Central Western Asian countries as well. Number of publications, again, I won't go into the details, but this is share in technologies considered from BECS, DAC, and so on. Just this is a interesting point to look at in terms of the awareness in the research community in terms of the importance of CDR, but often there is a bandwagon effect. When the topic becomes hot, a lot of people follow the crowd and publish in that area. There are special issues of journals which invite papers in the topical issues and so on. So it's not always necessarily great advances being made, because a lot of the papers tend to be epsilon advances on what is already known. Nonetheless, they add up to something important in the longer run anyways. So let's read up on the future action as proposed by this report, State of CDR. In the near term, innovations in CDR governance and policy making are mainly expected at national and supranational levels. Tailoring to specific country contexts will be key. To read further, at the UNFCCC level, the main task in terms of CDR policy and governance lies in developing robust accounting rules for CDR and establishing trusted monitoring, reporting, and verification frameworks, strengthening rules for reporting on land-based biological removals, and creating additional guidance for methods like DACs, direct air capture, and carbon sequestration, or enhanced rock weathering. This will be relevant not only for national inventory reporting, but also in the context of establishing international carbon trading under Paris Agreement's Article 6.4 mechanism. Yet UNFCCC inventory rules, currently based on IPCC guidelines from 2006 to 2019, are unlikely to change without the explicit request of national governments, primarily those that want to have the outcome of DACs or enhanced rock weathering recognized in their official national inventories. So the nationally determined contributions have to get credit for sequestering additional carbon, so they will push for some of these protocols, rules, policies, thereby helping reduce net emissions and fulfilling pledges made in NDCs. It's UNFCCC There are three C's. I keep skipping the third C, but you know what I mean. Beyond the UNFCCC, process action at a multilateral level can be expected primarily in fora like the CDR mission under Mission Innovation, established at COP26 in 2021 at Glasgow, with an official goal of enabling CDR technologies to achieve a net reduction of 100 million tons of CO2 per year by 2030. While limited institutional capacity may hamper in achievement of this goal, this platform, co-led by the US, Saudi Arabia and Canada, may contribute to enhanced governance and policy making through facilitating exchange of best practices and mutual learning on technology development and MRV frameworks for novel CDR methods. Of course, the motivation for pushing CDR is different for different countries. Saudi Arabia would like the fossil fuel business to go on for some time, and CDR can help make that happen. Canada and US generally are not big fans of signing on to agreements, so Australia as well, and Australia also sells a lot of coal, so we have to keep all those things in mind. Looking at tons of CO2 removed annually from 2020 going to 2050, this is an extrapolation of where we are and where we would end up, but where we would have to be for DAX, biochar and BECCS. So announced carbon dioxide removal targets from industry groups and companies imply faster growth than has been seen historically for most technologies. So they are optimistic about the future of CDR. Again, as I said, technological promises that may or may not be fulfilled. Squares represent built capacity here in 2020 in three examples of CDR. So you have DAX, biochar and BECCS here, 1 million here, kilotons here and kilotons here. Okay. Those are the three technologies with carbon storage. Circles represent announced plans for capacity addition, so where we will end up into 2030 or so. The shaded areas for each CDR method show how the last year of company capacity announcement could grow to meet CDR socio-technical potential by mid-century. The low and the high data points in 2050 represent the range of maximum potential removal, which is dependent on biophysical limits, which I have podcast on, you can look up, economic costs and side effects of deployment. So where we would end up and so on. So the process of innovation for carbon CDR consists of a sequence of interlinked stages that feed back and build on one another. These stages are broadly split into two categories: supply factors and research and development, so demonstrations and scale up, and demand factors, so niche markets, demand pull, and public acceptance, which we will look at in a minute. So supply factors of course include R&D pushing technology out, demonstrations making it to see that it is possible, technology readiness levels, costs and potential mitigation potential, and scale-ups. And they have feedbacks. Of course, demonstrations affect R&D for improvements and scaling up and so on and so forth. In the on the demand side, you have niche markets which demand scale-ups, demand pull which requires scale-up, and public acceptance which is going to affect R&D as well. So publications, this is a total number of publications on CCS per year from 1990 to 2021. So you can see that it peaked in 2017 and has remained low, but maybe it's growing again. So these things depend on the various supply and demand factors, funding available, etc. In terms of public perception, share of original tweets on carbon dioxide removal that express either a positive or a negative sentiment over 2010 to 2021. Trends in sentiment: positive green arrow, and negative red arrow over time. Tweet counts are for different CDR methods, and definitions are of course what we already used. CDR in general has equal amount of negative and positive sentiments, whereas ocean fertilization is mostly viewed negatively when you look at the tweets. There's been a lot of debate among the scientists about whether this is feasible, sustainable, co-benefits, side effects, hazards, etc. So people are left with a negative sentiment about it. Enhanced weathering so far has a lot of positive sentiment. Ocean alkalization also has a lot of positive sentiment, but these are always one step away from a disaster. So if you experiment at a large scale and something goes wrong, these can turn negative very quickly. Biochar, again, a lot of co-benefits, so people are optimistic about it. Afforestation, reforestation, there is again a lot of debate here about whether this is really worth doing. If it's a zero-sum game and you focus on planting trillion trees, what is the resource limitation for other methods, for example? Ecosystem restoration, soil carbon sequestration has a lot of positive sentiment. BECS is even on either side. Blue carbon management, coastal ecosystems, good awareness and positive sense, and DAX has a lot of more positive sense than negative sense. Tweet counts, you can look at each category. I won't go into the details, but for whatever reason BECS is going down because I think again there is a lot of debate about its impact on land, food security, crop yields, food availability, access, quantity, quality, etc. all those good things. And if you look at global increase in CDR patenting activity, again there is patent count, which is peaked in 2018 or so, but data is truncated here because of lack of availability and so on. Percent of total patents by a country, so in many countries the CDR in China, for example, number of patents dominate. It's almost 90%. And United States not so much. This is the World Intellectual Property Organization and other. Percent of patents by methods, again here direct air capture dominates, especially did early on, still dominant, but you have other methods like BECS picking up, as well as some generic CDR. So lots of experimentation going on, land CDR, enhanced rock weathering, ocean alkalization, iron fertilization, and so on and so forth. Number of publications, so this is exponential growth in the scientific literature on CDR over time. Total number of scientific publications on CDR per year from 1990 to 2021 with various indicators I won't read. There are methods involved and so on. But if you look at the illustrative CO2 removal and storage pathway for production of harvested wood products, during the carbon sink phase, carbon is removed and stored incrementally by biomass growth in forests. So here you have carbon sink happening. This is total CO2, and this is a scale that you can look at, number of years, so how the forests grow and mature, and then you begin to harvest wood for products, and you begin to basically cut down the forest so that sequestration is cut down, but you lock it up in wood, and then the wood, harvested wood products, decay over time, releasing the carbon from the storage, whereas the biomass releases over this period. So it's very schematic, but you see how the number of years for which you can put away CO2 with this method is seen here as a schematic. Global managed forest sinks in million tons of CO2 per year. Net managed forest sink less indirect effect. So indirect effect can actually increase the flux in the net managed forest due to things like CO2 fertilization and faster growth and sequestration of carbon in the trees, enhanced soil carbon, and other indirect impacts, as well as how they affect the carbon, soil carbon, water cycle, groundwater recharge, carbon sequestration in the soils, and so on and so forth. So Obviously there is large uncertainties here, so you have to keep that in mind, but you can see that it can be billions of tons or just a couple of thousand million tons, couple of billion tons. Estimate of current carbon dioxide removal deployment. So to worry about deployment going from research and potential. So here novel technologies include BECCS, biochar and other novel methods. Conventional CDR is of course methods on land. So you can see we already talked about 2 billion tons being removed by land methods and a small 0.002% being removed from novel approaches. But if you look at deployment of various methods for generating carbon sinks into the future, looking at 2030, measured in million tons of CO2 per year, gray projections indicate a lower, so linear and upper exponential extrapolation of 2020 to 2025 deployment data. So things that are already in the pipeline out to 25 are extrapolated to 2030. The gray crosses indicate 2030 deployment if only currently in deployment projects are completed. So if you project on how the deployment will continue to grow, then you will end up here for BECCS, DACS, biochar and other. But if that doesn't happen, then you end up on a lower scale. Biochar is not estimated there. And there is the harvested wood products, and you can see that the scales are different. Here it is 100 million tons of CO2. Here it is 260 million tons of CO2. Looking at cumulative stored carbon, as you remember from other podcasts, cumulative CO2 corresponds linearly to the warming, so we have to always keep track of that. So deployed CDR, and then there are various details in terms of linear growth in deployment, exponential growth in deployment, deployed CDR already, and with other linear growth in deployment and exponential growth in deployment. Okay, I won't go into the details, but this is of course projections which always have uncertainties because they are based on various assumptions. Scenario definitions used in this report likely to keep global temperature increases to degree C or lower. So we have already talked about warming limits of 1.5 and 2 degrees C. IPCC categories call them C1, C2, C3, and the descriptions are that below 1.5 degrees C with no or limited overshoot. So for example, now an El Nino is supposed to happen in 2023, and many are already raising alarm that temporarily we might cross 1.5 degrees C because the ocean will release a lot of heat during an El Nino if the El Nino is very strong. Does that mean anything dramatic will happen? Not necessarily, but we may just quickly go back to below 1.5 degrees C if the La Niñas can come back the following years or neutral years and so on. So these are scenarios of if we overshoot, how long we may stay above and when we may come back. This is below 1.5 degrees C with high overshoot and likely to be below 2 degrees C. And quantifications are involved here. So less than 1.5 degrees C peak warming with greater than or equal to 33% chance, and less than 1.5 degrees C at the end of the century with greater than 50% chance, temperature overshoot limited to less than 0.1 degrees C, and so on and so forth. Peak warming levels 1.6 with a range of 1.4 to 1.6. Here 1.7, 1.7. Warming level in 2100 with 50% probability. How many number of scenarios were simulated by models? This is at 1.4, 1.6 with some range of potential overshoots and so on. So this is global net CO2 emissions in scenarios assessed in the IPCC assessment report AR6. This is the upscaling of carbon dioxide removal methods under different pathway categories as described in table 7 here. and these are novel CDR's contribution and conventional CDR contributions. Details, but still just have a look. We have already talked about this. So there is the emission reductions dominating mitigations out to some 2055 or so, and then mitigation activity should dominate by sustained CDR, assuming again that the technological promises come true. And of course these are the min-max ranges, so take it for what they are. Future projections are always highly uncertain. So conventional CDR on land and novel CDR. So obviously novel CDR has to pick up and start running the relay race very quickly. Looking at cumulative CDR from 2020 to 2100 in gigaton CO2 in the assessed pathways, with the various scenarios C1, C2, C3, and the total for all pathways and the number of scenarios performed. Let's just look at total CDR. Number of scenarios at 407, total CDR at 700 with a range of 450 to 1100 gigatons. Of that, 360 from conventional CDR, novel CDRs picking up the weight and reaching 400, BECS contributing 330, DAX at 29, and enhanced rock weathering right now at 0. So again, just remember that these are projections, so always pay attention to the details that go into making these. Emissions trajectories across focus pathways and sectoral contributions to CO2 removal, CO2 emissions and removals at the time of net zero CO2 and net zero greenhouse gases. So you have various things here like AFOLU, agriculture, forest and other land use, for example. So annual GHG emissions, where we are and where we have to head if you remain in positive emissions, irreducible emissions that we mentioned, and what have to be removed. So net emissions from AFOLU CO2, AFOLU CO2, and negative emissions. This is focus on renewables and focus on carbon removal. So there is the demand reduction, renewables giving us the reductions of moving away from fossil fuels, and carbon removal through CDR and so on. So these are the various estimates of the time of net zero emissions. So focus on demand will give us 2059 time horizon, focus on renewable 2068, but focus on CDR will bring us to 2048. Again, just based on technological promises and assumptions about readiness levels and so on. At the time of net zero, the emissions focus on demand will give us some numbers, focus on renewables and focus on CDR. So CDR typically ends up with more CO2, which includes transportation, residential, commercial, industry, and land use, energy supply, and novel CDR, and so on and so forth. I'm not being very detailed here because these are kind of estimates, and I'm always worried about when and how rapidly we will scale up the CDRs, especially the novel CDRs, and will a big game changer really come along. Okay, these are again additional CDR scenarios from 2020 to 2030 and 2050. So various numbers from 2 degrees C or lower scenarios for additional conventional CDR, additional novel CDR, and additional CDR overall. So focus on demand reduction, renewables, carbon removal, nationally determined contributions playing into it, and long-term mitigation strategies. So various numbers, but here you are, additional CDR from 2020. This is the 0.96 ranging to 3.0 to very high PM 2.5 today, and I have the windows open. By 2030 you are reaching 0.96 gigaton CO2 per year. 2030 estimated at 4.8, but could be minus 0.58 to 13. Okay, and for others the various numbers. So focus on carbon removal typically is the big one, and it's unclear how CDR will play a role in the NDCs, the nationally determined contributions, and the gaps in where we need to be basically say that countries have to up their plans for CDRs. So this is where the CDR gap comes in terms of where the current CDR is and where we have to go. So this is the CDR in Paris relevant scenarios. So focus on demand reduction, giving us 48% GHG reduction by 2030. Focus on renewables, giving us 31% by 2030, and carbon removal giving us 33%. But if you look at conventional CDR, which is land-based and novel CDR, remembering the numbers we looked at, this is where we need to be. So where we are likely to be and where we need to be, that's the gap. And here are again the NDCs, unconditional and conditional. Unconditional is where countries like India will do what they want to do anyways in terms of afforestation, renewables, fraction of or GDP intensity, so energy intensity of GDP and CO2 intensity of energy and so on. And conditional NDCs are where they will want climate finance or financial assistance to implement some of the mitigation strategies, actions. Okay, so various numbers again for the 2030 horizon and 2050 horizon. Take the numbers for what they are worth, but one thing to notice is that by 2050 the scenario median and ranges are fairly large in terms of the gaps of where we have to be and what the committed CDRs and Paris relevant scenarios are. Okay, so slightly longish, but good that we finished it. So 3 podcasts amounting to more than an hour, but this is a really important topic and I have been quite brief, but hopefully it's still useful, especially if you want to follow up on your own with the report and the references therein. Okay.